Calculating electrical loads for apartment buildings with multiple meter banks involves several steps to ensure code compliance and proper system sizing. You can apply a demand factor to the total volt amperes of the 3 meter banks before applying individual demand factors. Here's how to approach this calculation. The total load calculation begins with summing the individual loads of each meter bank. In this case, you have 3 meter banks with a total connected load of 3,157,333 volt amperes. You can apply a demand factor of 0.23 from table 220.32 of the National Electrical Code to this total connected load. Applying the demand factor results in a calculated load of 3,157,333 volt amperes multiplied by 0.23, which equals 726,186.59 volt amperes. This is the demand load to be used for your service size calculation. The bus rating should be based on the sum of the currents after applying the demand factors to each individual meter bank. Firstly, calculate the current for meter bank 1. Given a load of 1,167,516 volt amperes and a voltage of 208 volts, the current is 1,167,516 volt amperes multiplied by the demand factor of 0.33 divided by the voltage of 208 volts multiplied by the square root of 3. This equates to 1069 amps. Secondly, calculate the current for meter bank 2 with a load of 1,177,533 volt amperes. The calculation is 1,177,533 volt amperes multiplied by the demand factor of 0.33 divided by the voltage of 208 volts multiplied by the square root of 3. This equals approximately 1079 amps. Thirdly, determine the current for meter bank 3. With a load of 812,284 volt amperes, the calculation is 812,284 volt amperes multiplied by the demand factor of 0.38 divided by the voltage of 208 volts multiplied by the square root of 3. This equates to 857 amps. Now, sum these individual currents to determine the bus rating. By adding 1069 amps, 1079 amps, and 857 amps, the total is 3005 amps. Therefore, the bus rating of the switchboard should be 3005 amps based on the sum of the individual currents after applying their respective demand factors. Regarding code compliance, particularly section 230.90 exception No. 3, this section addresses the installation of overcurrent protective devices with an aggregate ampere rating that exceeds the ampere rating of the busway or other equipment on which they are mounted. The critical condition for this exception is that the sum of the interrupting capacities of the individual protective devices must not exceed the interrupting capacity of the busway or other equipment. This means that while the sum of the breaker ratings can exceed the bus rating, the bus must be able to handle the fault current that the breakers can interrupt. In your specific case, you have 3 breakers with a total rating of 3,400 amps installed on a 2500 amp rated bus. If the sum of the interrupting capacities of these breakers does not exceed the interrupting capacity of the 2500 amp bus, this configuration is acceptable. This is because the purpose of the overcurrent protection is to protect the conductors and equipment downstream from overloads and short circuits. The breakers are sized to protect the respective circuits, and the bus is sized to handle the total calculated load. In summary, you can apply the demand factor of 0.23 to the total volt amperes of the 3 meter banks before applying the demand factor from table 220.32 to each individual meter bank. However, the bus rating should be based on the sum of the currents after applying the demand factor to each meter bank individually, which in this case is 3005 amps. Lastly, ensure that the installation complies with section 230.90 exception No. 3, verifying that the sum of the interrupting capacities of the breakers does not exceed the interrupting capacity of the bus.